Miss Danny, we can't hear you. You're muted.
Sorry. That's better, right? Oh, Lord, I'm
Yeah.
sorry. I'm sorry. Thank you for telling me. So, I didn't realize I was
trying to
muted.
tell you in the chat.
Say it one more time.
We're trying to tell you in the chat.
Oh, sorry. It's hard to, I see it. There it is. Yeah. Okay. Sorry, girls. So anyway, it's going to condense and then you're going to get big drops of rain that start to fall because they're very heavy. All right. Now, second stage. Now, these people really get looking at, oh, is the thunderhead all right? Because it's spreading out. And this is where it's very mature. It's ready to start dumping serious rain and wind down. It does. And you can see lightning occurring.
Yeah.
So this is when it is actively raining. So you see those thunderhead type clouds right before it rains. And is when it is raining, you don't usually see these so much because you're underneath of it in the rain, right? Like it's hard to see it. This thing at the top right here with this bar's in the way, this is what Milo said, anvil. What's an anvil?
It's and
Wait a minute, no hand. Bailey?
It's something that people would use to make different tools or armor.
Yeah, it's a blacksmith's tool, right? And you can use it for all kinds of things, but it has that point on the end that you can use to make circles and look up a flat top. What were you gonna add?
It is normally combined with a forge to heat the metal and a hammer.
Okay.
So you heat the metal and then you put it on the anvil.
Yeah.
Hammer and heat it, stick it back into forge to heat it back up.
Yeah, so basically this is the shape though that we're looking for. Yeah, I was gonna say, in cartoons, this is the kind of thing that the Roadrunner drops on Wile E. Coyote, if you've ever had the pleasure of watching one of those old awesome ones. So this is your mature stage. This is when it's raining. You've got this cool air sinking down and it's creating downdrafts. You can see the way the cold air is pushing down there, right? And then lastly, you're gonna have your dissipating stage. So this is when the downdrafts basically end the storm because they pulled all that moisture back down to the ground. And the supplies run out. So they're going to slow down and stop. And then this stage just lasts until it's done having gravity's effect on it. Because gravity will take whatever little drops are still heavy. They won't be pulled down so rapidly by the wind. They'll just kind of fall until they run out. So thunderstorms can vary in severity. So, and they can also bring different kinds of severe weather with them. So this is when you start getting alerts on your phone or your weather station. Good question. No? Okay. So you have severe thunderstorms. We've all seen that, right? You have lightning, you can have wind, you can have hail, floods, and tornadoes. Okay. Here's the thing about hail. Why do we get, what's hail? Where's it? Can somebody explain how hail's made, Jack?
It's it's when the rain passes through the part of the cloud that's below freezing,
Mhm.
mixes with the ice that's already.
Yeah, there's usually some sort of condensation point where you've got the raindrop that is going to condense, right? All the water condenses around it and it falls down and it's frozen. And then what happens? Bailey?
But more and as it goes, so it gets bigger.
Yep. And what else?
It recirculates, it keeps going to.
Yeah, that's the crazy thing. It catches an updraft and goes back up, where it puts on another layer of ice and then catches another updraft. It keeps doing this until it gets so heavy that the updraft can no longer support it and it sinks down and comes like a big old chunk of ice. And in a minute, I'm going to show you a cross section of one and you can see exactly how it's formed ice and every like a tree. It's like a tree. And then you can have floods and tornadoes. So let's talk about severe thunderstorms quickly. So this is when you've got an increase in the temperature difference and stability of air. And basically of all annual thunderstorms, less than 10% are considered severe and even fewer are supercells. So what do we want in this blank, Jack?
Supercells?
Supercells. Okay, so what are supercells? Okay, supercells, and you hear this is one of the ones where meteorologists get like, excited. So these are these self-sustaining powerful storms. So they're characterized by intense rotating updrafts. So that's what we're talking about, where you can get hail, that rotating updraft. And then they can have really, really, really fast winds. So these guys can last longer because instead of the downdrafts just sucking all the moisture out of them, kind of taking the power out of the storm, they cycle around and around an awful lot. So you get the moisture right back up in the cloud where it came out of. All right, now lightning. Lightning is cool. Scary sometimes, but cool. I like the whole phenomenon here. So it's
hotter, it's like 5 times hotter.
It's crazy. Yeah. So you've got electricity and it's caused by the rapid rush of air in a cumulonimbus cloud. Okay. Think about motion and electricity. Do you have an experience with maybe moving and then having electricity acting on you? What do you think?
Like like sometimes in the winter when you like push your like bed, like your blanket on you, like there's forms of electricity.
Yeah, exactly. Those little sparks. Uh-huh.
Like sometimes when I take a blanket out of the dryer, like will crackle.
Yes, okay. So what we're dealing with is the same thing. It's just, it gets in one big collection, one big stroke. Were you gonna add anything?
Two common examples are rubbing a balloon on your hair
Yep.
or walking across a carpet with thoughts going and then touching the doorknob.
Oh, yeah.
Two famous.
You ever done that in the dark? If you've got like a blanket that gives you static, you can actually see the sparks
Yeah,
sometimes.
Yes.
It's pretty
Or
cool.
you go down the side of like a playground.
Yes, okay, yeah, great example. So what happens here is your lightning bolt is forming from this friction, which you got updrafts and downdrafts, right? They're passing each other like this. So you're getting friction and they're separating electrons from some other atoms. So they're pulling off electrons. How are electrons charged?
Negative.
Yeah, or negatively charged. All right, so they're pulling them out. And then you've got the return stroke. So this is when the lightning is going from the ground to the cloud and it illuminates the channel. So here's what happens. You've got the negative stuff coming down, and then you've got the lightning going back up. A lot of the lightning that you see is actually going from the bottom up, but it happens so fast that it's hard to see. So, but that does happen. That's the return stroke. So you have it going right back up. All right, so how hot is it? How hot does the air get? Yusuf, do you know?
5 times hotter than the sun.
5 times hotter than the temperature of the sun, which it says there. What's the actual temperature? Anybody know? Yes, Leah,
30,000 degrees Celsius.
30,000 degrees Celsius. That is hot, super hot, 5 times hotter than the temperature of the sun. So then you've got air around it. What happens to the air around something that suddenly goes from, 65, 70, 75 to 30,000? Yeah, what were you gonna say? Yeah, rapidly heated up. And what does it cause?
Thunder.
Yes, thunder. Okay, thunder. Thunder is caused because this air gets crazy hot, crazy fast. It's basically that sound wave that you're hearing. It's getting compacted and shoved out into everything. It's not nobody. You're muted. She fixed it. Okay. All right. Let's take a sure. All right. So you may see lightning much sooner than you hear thunder, even though they begin at the same time. Why is that? Why is that? Wait. Let me see. Somebody who hasn't answered me yet.
Jack.
James, why do you see the lightning before you hear the thunder? Yeah, why? There you go. Light travels faster than sound. So you see it before you hear it. And there are about 7,500 forest fires every year, and we can blame lightning. All right. So a channel of partially charged air moving between positively and negatively charged regions, typically from cloud to ground. What is this? Anybody got it? In your notes? Anybody got it, Alex?
I'm not sure of the technical name, but like a more colloquial name is skylighting type of thing.
There you go. Okay, so it's called a stepped ladder. I didn't name it, but it's called a stepped ladder. Now, the next one here, you got some positively charged particles moving through the channel from the ground to the cloud. We talked about this a second ago. From the cloud to the ground, or headed that general direction, is a stepped ladder, but going back up is called what, Caitlin?
It says from the ground to the cloud.
Yeah, that's right. It is going to go from the ground to the cloud. What do we call that one? Piper?
Return stroke?
That's a return stroke. Bingo. Excellent. All right. So what's the sound that's produced? Chloe, what's the sound that's produced if you get super hot air? Thunder it is. All right. I knew I'd make her talk. All right. Now, these are fun. These are some variations on lightning. We've all seen lightning. Some of these you've probably never seen. I would love to see some of these. Okay, so sheet lightning, sheet lightning, spider lightning, ball lightning, blue jets, red sprites. And also, I don't think your curriculum mentioned, but there's also a gigantic jet. Ooh, fun name. So here's your sheet lightning.
That's cool.
This is lightning with its brightness being diffused by reflection within the
I would
clouds.
sit down my Zeus myself.
So really, you've got all of that moisture in the cloud.
Thunder.
Shh, shh, shh. Listen, all those little tiny water droplets in the cloud, and the water is getting refracted through them. You ever like shine a laser on a water drop or something? You can see how the light, or even into a glass prism. That's fun to do. And you can see the light kind of go everywhere. That's how you get sheet lightning. Now, spider lightning is interesting because it goes horizontal.
Looks awesome.
And often seen on the underside of stratiform clouds. You may have seen this. This is when instead of going up and down, this lightning's kind of going out like this. And it can sometimes come from like a center point and then it goes sort of out like that, like an upside down umbrella almost underneath the cloud. So it's pretty cool. Ball lightning. Okay. I have a couple of videos here real quick.
I see.
Ball lightning is a rare phenomenon. And it's the kind of thing that for the longest time, scientists were like, don't believe it. It's a hoax because it's really weird.
It looks like it's coming from the moon, right?
Yeah, kind of sometimes. So here's the thing about it. They've decided somewhat recently that, or contemporary at least, that it is a real thing, but they have no idea what causes it. And they don't know what it is. They suspect it could be plasma because of the lightning activity and whatnot. Or it may be light from the lightning trapped in like a bubble of air.
You ever heard of this? Like,
The spook light? No, what's that?
it's a kind of like legend.
Uh-huh. Yeah.
South Dakota. Or this one area, stuff that's pretty much like the ball lightning.
I have not heard of that. That sounds cool. So they can go from being pea-sized to being like real big. So there's two videos here where you can really where you can see it. And these are actual just people like with their phone. So they're not the greatest quality. And then of course, there's always somebody on the news who has some crazy story and it's just worth watching because it's entertaining.
It's full.
So
Look at this.
here's this one. Sorry. See it occur up in that.
I can't.
You watch, you'll see it. Watching this top one. This is slow-mo. Oh, I don't know. Well. There it is. You see it? This is in the way. There it is. One more time, because that bar is in the way.
So small.
Yeah, I'll back it up a little. There you go. It's fine. See at the very top, look. See it? Sorry, it was being blocked by that bar there. So it was there for a second, but not too long. All right, now this one's really interesting too. Yeah,
This is not a midnight.
yep. This one doesn't have sound. This is like somebody's security camera or something, but if you watch, it'll go off to the left of this lightning stroke and it's slow-mo, see? But you'll see it if you watch. Hold up.
Can't see the ball.
Hold on, watch. There it goes. They put it in a little spotlight there so you can see it. So if you watch again from the beginning, now you know where you're supposed to be looking. Right off there to the left, it's tiny, tiny, but their camera picked it up to the point where they can go, okay, now look, it's right?
I
Weirdness.
can see it a little.
You can see it a little. Okay, these people are just too fun not to share. I love these people.
This is the National Weather Service's Lightning Safety Awareness Week. TV6's Dustin Wonk met with a family today who had a close encounter with a rare phenomenon called ball lightning, which entered their home. The event happened about 30 years ago, but the Bashan family
30
says
years.
they'll never forget.
Oh, wow.
Bluish ball come floating out of that room.
Joe Bashan of Gwyn came up close and personal with ball lightning. He and his wife Rose were entertaining friends on a hot August day in 1980. Joe was making a drink when he turned around
I could see a white blue ball.
and there it was.
You're speechless when it happens, you don't experience anything except what's going in your eyes. I was just staring, I was in awe.
The ball entered the room from the
I
hall.
love the pantomime here, how the
Put
ball
off the
moves.
ground and touched the TV, disabling it. The whole event took about 15 seconds. When the ball came into contact with the TV, it imploded with a deafening bang and it shook the house.
It was just a very loud bang. And poof, it was gone, and everybody's kind of just standing there staring at each other looking.
They described it as about the size of a soccer ball floating silently in the air. Joe says it was a bright blue and white and looked more like liquid. According to the American Meteorological Society, ball lightning is rare, so online footage is scarce and
Yep.
often low quality. The Bashans have no footage of their encounter, but Joe says
not.
he'll never forget it.
If I was the only one that seen it, I probably wouldn't even talk about it. You know, like a UFO
On that August day, there were no thunderstorms until after the ball was gone. Thankfully, no one was injured.
Then it just imploded with the loud bang.
It's a loud bang. In case you didn't get that, they said it like 4 times. It was a loud bang.
Okay,
Loud bang.
so even the guy says,
Sorry.
even the guy said they were making it rain.
There it goes. Sorry, it's being weird. Yeah. So, all right. So moving on from that one. All right. So we've got also, oh, I don't have any more videos, I don't think. Yeah, no.
The red sparks.
Okay, so we'll get there in a minute. I gotta move this to the center for a minute because it's messing up stuff. All right, so blue jets. So a lot of the pictures they've been getting of these, they're getting from the space station. And it's pretty cool. So, okay. So these are believed to be initiated as normal lightning is discharging between upper positive charge region of a thundercloud, so up here, and a negative screening layer is what they're calling it, that's present above this charged region. So these blue jets do occur, although most people don't ever see them because that's, I mean, it's right there, right? That's teeny. And it's, go ahead, go away. Oh, come on. Anyway, so they're very small, but it's cool. Look at that. I mean, right out of the top of the cloud, right? Y'all good over there? Parker. So that's a blue jet. Never seen one, probably won't ever see one. These next ones are just way cool. Yes, you said.
Oh, wow.
Oh, okay. So these are red sprites. They do. And these come in all kinds of different shapes. And they're apparently not that uncommon, but I've never seen them. I would love to see them. So they vary in range of shape and they're usually red orange. Sometimes they're blue green. And they are triggered by discharges of lightning, positive lightning between the thundercloud and the ground. Now, they named him after the mischievous sprite, like in Shakespeare's work, there are sprites like Puck or whatnot. And then sprite is just a mythical creature. If you've done science biology with me, you've gone sprite hunting, so you know. Sprites is just a fun word. But they also made it stand for something because why not? So anybody want to read what that is? That's a great one. All right, Jack, what is it?
Stratospheric mesosphere.
Perturbations.
Perturbations resulting from intense thunderstormy electrification.
That is creative. You gotta love it. Super creative. All right, so those are red
Then
sprites.
put a slash between the mesosphere.
Yeah, now this is the giant jet. And again, they get a lot of these with that. These are more like the satellite and the space station that can catch these because they're up on top of the cloud. Yeah.
Jumbo jet.
So these are intracloud flash between middle negative and upper positive regions of the cloud. And these right here, these are telescopes. So somebody picked this up. And this is probably the super longest exposure on the planet to get something like that. Because see how bright the sky and the stars are. But that's amazing. And you'd have to be above a cloud to see it. So.
Wow.
All right, so wind.
Do they have it every single time a lightning hits?
No, not every time. It's just the conditions have to be right. Like in just kind of like every time you touch a doorknob, you don't always get shocked in the winter if you're wearing sneakers or whatever. But all right, so we have wind. Now, what makes wind? Wind is interesting. So sometimes the downward energy is not dispersed and it becomes concentrated, and that's when you get these things called downbursts. All right, so downbursts come in 2 forms. We're still talking about thunderstorms right now, okay? We have microbursts and macrobursts, and obviously, which one is stronger? Macro. Raise your hand next time. And how do you know, even if you don't read about it? Because of Yusuf.
Because micro means like very small.
Yes, and macro means big. Perfect. All right. Now here's the hail. Remember I told you I had a cross section? There you go. So you've got hail going down, getting picked up, circulated, picked up, and circulated, and it looks like tree rings. You can see, you got to cut that really fast with a really cold saw, I imagine. But if you get a good cross section of a hailstone, you can see how it's cycled through the cloud again and again. You can even see like, there's the initial one, there's this one, 3, how many times? Like 1, 2, maybe 3, 4, 5, 6, 7, 8, 9, at least 10 times, probably way more than that. So there's 2 characteristics that help hail form. You got water droplets existing in a liquid state where the temperatures are below freezing. And then they come in contact with ice pellets, so they grow. This is like, I did this in chemistry class, and maybe physical science too. But if you super cool water, and it has to be 100% pure water. So you can do this with certain distilled waters. and whatnot that you can buy at the store in a bottle. If you super cool it, like you put it in the freezer for a certain amount of time, you can take it out and tap it on the counter and the whole thing will just turn to ice. That's what we're talking about
Oh,
here.
I've seen that on-
Super cooled water, yeah, that is just ready to freeze as soon as it comes in contact. So what happens when you drop that bottle or shake it is you cause a little disturbance in the molecular structure of the super cooled water, and 2 or 3 molecules will just shift so that they lock together like ice does, because remember that causes it to spread, and it goes from, it goes from being this liquid that's kind of all blobbing around to a very structurized, crystallized almost look. And as soon as those two do it, or however many, then they just start going, and it's like a chain reaction.
Does it matter what temperature the freezer is?
Yeah, it has to, you can look it up. It's been a while since I've done it. I can't remember exactly. It's gotta be very cold. A typical house freezer can do it. I mean, it doesn't have to be anything special, but you have to leave it for a certain amount of time and not too long. Milo.
What about a deep freezer?
Yeah, it'll work too. Mhm. So you can try it. It's a fun experiment.
Like negative.
Wait a minute. What were you gonna say?
Yeah, I saw on a TikTok video, they kept it on like for like 2 or 3 hours.
Yeah, another thing you can do is if you're very, very careful, you can take the super cooled water, and if you have a tiny crystal of ice and you put it on a table or whatever on a plate, you can pour and the water will freeze as it'll freeze like a kind of like a dripstone effect, right? You can also do that. There's a chemical we use in chemistry class that we do that with. We put like 1 or 2 grains down of this chemical, and then we start to add it. And it solidifies because the molecules are locking in place, and that's what happens with the hail. Okay, this was the saddest thing. Yell, don't yell. This was the saddest thing that occurred with Ian, right? This was Ian, came through Florida. What is that right there?
Looks like a McLaren.
It's a McLaren. It's a McLaren. What is it? What is it? A 5? Something 5. Cole would know. Anyway, it's one of them. And this was in someone's garage in Florida during Hurricane Ian. And yeah, it went bye-bye in the flood. Were you gonna say something, Milo? John, turn your McLaren into a beautiful,
Don't ruin the beautiful.
yeah, oh, it's an F1, I
At
believe.
least it's not a Ferrari.
Not already.
If it's a Ferrari, that would be a bigger size.
I think that's what that is.
I know.
Yeah, so that's a McLaren F1 is what it was. And so that means it's how much, I'll tell you. And it in here,
Can't stand to see that.
it's expensive.
Yeah, any supercar going down is sad, like the McLaren.
Right.
At least it's not that bad.
So what are we looking for here? What occurs when you've got weather systems that result in storms that move what? Okay, Alex?
Water.
Yeah, so basically slowly is what I'm looking for. When you have a storm that moves slowly, it's going to create more flooding, and that is not great. So this car is about, this says it's 20 million. I don't know if it's an F1 or not, but anyway, it's
20 million to attain it.
yeah, okay, to attain it. Whatever, somebody should have probably driven it out of town. So if rain falls faster than the ground can absorb, which we've already talked about, and it can't get to rivers and streams, or those are flooded, this is what's going to happen, and you're going to lose your McLaren. So
Why?
there were pictures of it in the garage. There were so many pictures of it. It was so sad. So tornadoes. All right, this is a great picture. So you've got violent whirring column of air in contact with the ground. So what is it called before it hits the ground? When it's just whipping around and it's starting to pull, but it hasn't hit the ground. Yeah.
Funnel cloud.
It's a funnel cloud, right? Okay, now there are similar structures like this, funnel cloud looking things that occur over water. Do you know what they are? Yusuf, do you know what they are?
Cyclones?
No, I was
Water
talking about water spouts. Yeah, you got it right. So you may see these like over the lake sometimes or over a pond. They're called water spouts. They're not dangerous, but they look scary if you don't know what they are.
Frogs, rain frogs.
Maybe a little. So
Or fish.
tornadoes will form when the wind speed and direction change suddenly with the height, and it can go from horizontal to vertical rotation. So you've got the storm that's doing this, and then it just kind of whips down, right? And they don't usually get more than 200 meters in diameter, and they can usually only last a few minutes. That's the good thing about tornadoes. They spin themselves out, or they become less stable as a system, and they just sort of knock themselves out, usually after several minutes. Whereas hurricanes can go on for like half a day as it slowly moves through your your area, but these guys are fast, but you don't get much warning with them. Like a hurricane, you know, it's coming for days, a tornado, not so much. And these are strange in that, so a hurricane can do damage to a wide area. But you can see, like you've seen the aerial photos, right? Where a tornado went through a little town and you can see just this flattened path. When I was in high school, y'all back up. So when I was in high school, my French teacher came in and told us this story. We had a little tornado. We don't ever get tornadoes in Virginia Beach, really rare, but we had one. And it was just little, it made the news because everybody's like, oh my goodness, it lasted like 3 minutes. But it was in her neighborhood. And she had a man working on her gutters at the time. And he was standing on the ladder, on the gutter, on the back of her house, working on her gutter. And this tornado went down her street. He's watching it from the back of her house. Over the roof, he watched the tornado go down the street. Now it knocked out the pine tree in the house across the street. It went into the house, completely trashed that house. Her house was perfectly fine. And he was standing on a ladder the whole time. So that's how weird they are.
We had a friend have a tornado go like right over the house.
Hey,
Jump it.
yeah, yeah, for real.
My mom lived in Kansas like most of her childhood, so she has a lot of like
Oy.
tornado stories.
Yeah.
Like one time, she was living on this like area, and there was a tornado coming, and my grandpa literally just like went out there
Mhm.
and like stared at it, and he said like, I said a prayer or something, and it literally just went like, whoop,
Yeah.
and it was like, there's weird though.
They're very, they can get very specific areas and it's weird. So here's how we classify them. They're classified on the Fujita scale.
Like F1.
Yes, there they are. Yeah, exactly. So these are classified on the Fujita scale. And this is basically the criteria we use. And this is the sort of damage. So a 0 just, you know, peels off some shingles from roofs, not a big deal. A 1 can, guys, pay attention back there. A 1 can strip mobile homes. You know, there's a joke about how mobile home parks are like magnets for tornadoes. I don't know why that is, but it does seem to be the case. And their roofs get turned off at 2. So when you get into 3, 4, and 5, this is when it gets really scary. These F5s are very rare, but they're massive and they're super dangerous. They can pick a whole building up. Mhm.
Yeah, like Vader says, it's happier than tornado in a trailer park.
Yeah. Wait a minute, I can't hear what James said. Say it again.
There's 1 second for healing.
Oh, gosh, I don't know. I would say a 4 probably, because it's picked up 4 or 5. It picked up her whole house, so it must have been.
Her house is like so small.
If you've ever seen the 90s movie Twister, it's not exactly scientifically correct, but it's all about, they're basically storm chasers looking for tornadoes. It's a cool movie. And they get an F5 while they're out there, and it's fun. It's not, like I said, not scientifically perfect, but it's fun. So tornadoes, how are they distributed in this country? So in this country, this is where you see them the most. And you can see how this shape kind of moves. They really like to form right here. What's this right here? Mississippi, that's right. And what's here? Alabama. So, yep, this is sort of, they call this area what? Tornado Alley, right? And they tend to form more in the spring and more in the late afternoon or evening. Yeah.
Danny, don't they also form in Indiana?
Yes, they form in, yeah, they do. These are all the places where they can form and move.
They're having the where has to be flat, right?
They do better in a flat area. Yeah, because the topography allows for that wind to kind of whip and come down. Now, safety. So we have National Weather System. They give you tornado watches, warnings, and sirens. Now, I will tell you this. If you have an iPhone, you can sign up to have alerts sent to you. Also, if you have a weather station like ours, and it will give you an alert that'll wake you up in the middle of the night if there's a tornado coming or you need to take cover for any reason. Smart thing to have. Used to be people just had weather radios in their house. And I used to, when I worked at the school where I used to work, we had one I had to keep in my office. And it just sat there, it was turned on, but it just sat there silently unless there was an alert, and then it would just start like really loudly beeping. So it's smart to have a system like that. If you don't already have that, I suggest you do it. You or somebody in your house. And this is the kind of thing like where if you set your phone to silent and do not disturb at night, it will still come through that because it's set up to.
I was gonna say there's also sirens.
Yeah, tornado sirens, but you're sleeping, you don't always hear them. But I'm sure. Have you ever heard them when they're testing them? They test them sometimes.
Yeah.
It's usually like a nice bright day, so you're not scared to death. Wait, what were you saying, Drew? Sorry.
Less than a week ago, I was around.
Wait. Yeah. Yeah, it's a creepy sound.
Or like old areas.
Yeah.
Should I be scared?
All right, so wait a minute, guys, we're moving on. So this is really cool. Somebody took a photo series and then they put them all, edited them all together. So you could see the evolution of this tornado. And I like that because you really get, it's like you can really get a good look at every little single attempt to make itself strong. And you can see where it kind of comes down there and just really starts picking up. Uh-huh.
Everyone's doing all the pictures of like. Yes.
Oh, yes, the evolution one. Yeah, it is. Uh-huh. I like this. It's a great photo series. I admire people who can do that. Now, this is crazy. Jason and I went to dinner last Friday. Yeah, at a place in downtown Alpharetta. If you haven't been to downtown Alpharetta lately, by the way, it is like so different than what it was a couple of years ago. It looks totally different. But they had a fire pit, and it was a fire pit with the glass rocks in it. You know what I mean? The little glass fire rocks. And it was a gas fire, so it was fed from underneath. But it around it was this semicircle brick wall.
Yeah, like that in the background.
Yeah, and it had these little holes in it. It was a very windy day. And so we went out there because it was so cool. I filmed some of this. This is exactly tornado activity, but it's fire. So you can really see it because it's more visible than the wind. So if you watch what's happening here, you can really see right there. See where it picks up? Now I have some of them in slow-mo. That's a slow-mo one. You can see how the flames start to cycle.
Looks like some kind
See
of
it?
magic fire spell.
Yeah. And one of these videos I got was really cool. You could see a big downdraft come in, and then you can see,
They look like breathing phoenix.
isn't that crazy? Like,
Yeah.
there it goes, picking up, trying to become something, and poof. And they were tall. I'm talking, some of them came up to like here, right past me. It was pretty wild to see. But you can see that activity on the ground exactly like you would if you were watching a tornado.
The
Wouldn't that
fire spell. Very fun.
What now? Yeah, you can see leaves to it too. Yes, Drew.
I'll tell you guys can do, and I've been able to do it because I don't have the right material. So basically, if you have a long plastic cylinder, maybe like this big, and you can cut it in half down the top, and then if you take it like
Oh,
this,
yeah.
and then you just slightly turn it so that it's off-centered, and you put a candle in the middle, it'll feed air through like
Yes.
this, and it will make a fire tornado.
Yeah, you can make a fire tornado, but you have to cut glass to do it. Yeah,
It's a big one. 'cause I can-
it's cool though. All right, so let's move on to the cyclones. Do you have anything else?
How do fire tornadoes form?
Okay, so that's what he was saying. So you have to have a glass
No, like a
cylinder.
real fire.
Oh, real fire, just like that. It's the same thing. You've got, so, and a great example is if you do the glass cylinder, you can see how it works, but you have to cut a glass cylinder down the center. So you have two like
Or
semicircle
plastic.
cylinders, right? And then instead of putting them together like this, you have, instead of putting them together like that, you offset them a little bit. So it's like this, instead of like this, right? And you put the little candle in the middle, and because it has heat, right? The heat's gonna rise. But if you think about it, the heat's gonna rise and it's gonna pull air in from here, and it's gonna pull air in from here. So when it's pulling air in from both sides to feed it, the oxygen, it starts the spiral. And that's exactly, it's similar, systems on the ground that'll cause tornadoes. And
But real fire, how does the heat come? Fire.
it depends where it's being fed from, what's feeding it. So tropical cyclones.
After nuclear bombs, those can happen a lot.
Oh, I hadn't thought about that because we haven't had one of those in a good while, and I hope we don't have one soon, but people are now saying, hey, we've got all these people fighting, so go away, I don't want you. So tropical cyclones, these are large, rotating, low pressure storms. So they happen during the summer and the fall. And what do we call them, Jack?
Hurricane.
We call them hurricanes. Now, if you are in a different part of the world, you may not call them that, and we'll get to that in a second. So this here is our, do you think? This is going to explain to you, it's very short. Sorry.
Hurricanes, typhoons, cyclones. But what's really the difference? In this case, actually not very much. They're all terms that we use to describe the very same weather phenomenon. A tropical cyclone with sustained winds of at least 74 miles per hour. They're also all low pressure systems that draw energy from warm water to fuel organized thunderstorms rotating around a central line. And each year, on average, roughly 26 of these storms spin across the planet. Okay, then, so what is the difference? Like real estate, it's all about location, location, location. Hurricane is a term that we use here in the Atlantic and the Pacific Oceans east of the international date line. But typhoon refers to a similar storm in the Pacific Ocean, but west of the date line and north of the equator. And the word cyclone, that describes any hurricane located
I don't
south
know.
of the equator.
I don't know.
Hurricanes and typhoons both spin counterclockwise, but cyclones in the southern hemisphere rotate the opposite direction. And no matter what you call it, hurricane, typhoon.
Yeah.
cyclones,
Coriolis, that's right. Very good. So Coriolis effect is why you got one rotating one way and the other. But yeah, so if you're here in the US area, we call them hurricanes.
Really what it
If you're in near Japan, China, Indonesia, they're gonna call them typhoons. And then if you're anywhere south of the equator, they're cyclones.
That's an awesome picture.
So
The upside down people.
so how do they form? All right, so they have to have two basic conditions. Lots of water from a warm ocean and then some kind of disturbance that lifts that air up and keeps it going up. If you keep that air going up, you're creating a vacuum. And due to Coriolis and other stuff, you're gonna start to get the spinning. So conditions exist in all tropical oceans except the South Atlantic and the Pacific west of the South American coast. So you got air rising, some disturbance. You get lots of rain being produced, and the Coriolis effect causes the moving air to turn counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. All right, so movement, where do they go? That's an eye, by the way. That's a shot from above, like a satellite image, straight down into an eye, and you can see ocean through it, which is really cool. So they move according to wind currents that steer them. So they often get caught up in with circulation of high pressure systems, and it can carry them west. So if you look at the way these are paths, you can see where they go. Some of them will come up here and they just kind of peter out. See, they turn too early. A lot of them hit right there. So this is showing, these are the typhoons right here, okay? Here, over here, these are gonna be what? These are hurricanes, yeah. And do you see that see here and here? Look at the gap in the middle where they don't tend to hit. That's the equator.
I hit nowhere.
Yeah, that's the equator. Now think about the way the winds flow around the planet. Remember we did the little thing with the arrows and the way that winds move? See, it makes perfect sense, doesn't it? Yeah, they're following those major wind currents. All right, so the development of a calm center of a storm. What do we call the calm center, Milo? That's the eye. Very good. If you're in the eye of the storm, I know it's a Hamilton thing, but if you're in the eye of the storm, it's really calm right in there. There's nothing going on, but around you is where the strongest winds are. And what do they call that, Piper? That is the eye wall. So it may be calm for a minute, but you're about to get smacked really hard. And you've probably already been smacked really hard because it has to pass you. So if you, wherever you live, say your little beach house gets the opportunity to be in the eye of the storm, it also means it got smacked twice because it got smacked as it came in and it got smacked as it left. It's interesting if you've ever been, I've been in the eye of a couple of them. It's really interesting.
Theoretically, could you
It's like,
follow the hurricane while staying in the eye?
I mean, I suppose if you're crazy enough. So tropical cyclones have stages. You have what they call a tropical disturbance. And this is when these are the weather guys that are like, I see a tropical disturbance, so and so many miles off the coast, and blah, 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 blah. And then you get a depression. Now, remember, these can go both ways. All right. A storm will build from a disturbance to a depression, to a tropical storm to a hurricane. And it can also downgrade the opposite way. So as it picks up speed and power, it changes from a disturbance to a depression, to a storm, to a hurricane. And then as it loses power, it goes back. You've probably seen this many times, right? We'll have a hurricane coming our way. By the time it gets here, it's different. It's a tropical storm. That just happened, didn't it? Which one was it? It was, what was her name? Nicole. Yeah. So Nicole, she downgraded herself when she hit. You should remember that. That's my middle name. So yeah, she downgraded. All right. So we use Fujita for tornadoes. We use Saffir-Simpson for hurricanes. So these are the categories. And category 1, 2, 3, 4, and 5. And it'll tell you what level of damage. Huh? No, 0. So you've got, even at 3, anything in here. So from where do we call it major? Yeah, 3, right. Anything 3 or above is major. And you got to watch out for those. You got to be very careful because that's not gonna be good. So yes, 3 or above. And they use wind speed, huh? Oh yeah, they're not fun. So they give you air pressure, potential property damage. These are the ways the category, the points they used for the category.
Yeah, McLaren destroying.
Yeah, McLaren destroyed.
I was so sad.
Oh my gosh. So you can see right here, these are different photos where they've taken pictures of this particular hurricane as it has moved. All right, and this one hit poor Nova Scotia, smack. Yeah, and you can see how it gets really strong right here because it's got that nice solid eye and it kind of peters out a little bit, right?
Just look like a gust.
If it comes inland, they lose energy. Why?
There's no water.
Piper, there's no water. Yeah, yes, exactly. So if it comes over land, that's not great. Now, what Ian did is it came in here and it did a little damage and then it went back out to sea. And everybody was like, oh, it's gone until it showed up in Nova Scotia. Remember, I told you guys when we were there, parts of that little island there were just devastated because it smacked it pretty hard.
He was like, I'm gonna move forward. Oh, no. I like
So
it.
here are some hazards of hurricanes. Obviously, you got storm surge. That's a big deal. That's when you got all of that water coming in, McLaren floating away. Goodbye. And yeah. And sometimes it can go 6 meters above sea level. That is really high. And it can cause damage with high tide and flooding, and your supercar can float away. So you've got hurricane advisories. Obviously, National Weather Service will give them, but you've also got NHC, which is National Hurricane Center. Specifically, those are meteorologists who are just total hurricane nerds. Good for them. And this kind of tracking has reduced death tolls over the years, thank goodness. And obviously, that's the goal, right? I mean, you tell people to leave.
But
Then
we
you got, like I said, the townies that don't.
But we also put people covering them.
Yes, of course. We send our meteorologists out there with cameras. I don't know why they
I
exist.
wonder how that started.
I don't know. So then you have these issues of recurring weather. This is another kind of weather system. So this is when you have,
Instead of the death sentence.
y'all, this is when you have things like floods and droughts and heat waves and cold waves. And these reoccur time to time. You may live in an area that is like a drought and flood area. Like think about the Nile. If you've ever studied the Nile River, the banks of the Nile will go from drought to flood to drought to flood. And it's, yeah, but it's a pattern. Yeah, but it's a pattern they anticipate and their agriculture is based around that. And then you get heat waves and cold waves. And sometimes these are, expected and sometimes they're not. So floods, this is the same area in these two pictures. They basically the same area. They took this picture in the same area. So floods can occur with large storms and you can get small amounts of rain per hour, not an issue, but if it rains for 18 to 24 hours, then you have a problem. And then droughts are when you have extended periods of below normal rainfall. Who remembers the 100-year drought at Lanier? Do any of you remember it? You would have been pretty little. Do you remember it? You could walk out into the lake bed to where the buoys were and past. And there were parts of Lanier, because Lanier, is a man-made lake. Remember, we talked about it. There was a raceway where people used to go and it had concrete grandstands and they surfaced when the water was in drought.
Was it like just the grandstands or?
Just the grandstands that surfaced. There were some tires and stuff that showed up. It's kind of gross.
I wanted to kind of see the raceway.
Yeah, there's pictures of it. You can look it up. So the extended periods of above normal temperature, we're going to call heat waves. So same systems that cause high pressure systems and droughts can also cause heat waves. And that end up blocking the cool air masses from coming in just because of the way they're situated. And humidity reduces the body's ability to evaporate perspiration. So you can get stuff like heat stroke if it's too hot and too humid, which is not great. So now you got a cold wave. Sometimes people call it a cold snap because snap sounds more cold than wave, I guess. And this is same thing, but the opposite, right? Same, but opposite. It's when it's too cold for too long. And you guys know the problems that can happen if you're too cold for too long.
You can
You can freeze. Okay, so now we're gonna play a little game. So I'm gonna tell you what's at the top here. I'm gonna let everybody take a guess at what goes where. So I'll put this down here at the bottom before I show you first. Number of fatalities.
Oh, wow.
There's your numbers of fatalities. Now I've given you, okay, I can put it there. Now I've given you can't this thing go away? I swear I could make it go away. Oh wait, there it is. Okay. I've given you the numbers over here, and these are our options. So I would like to know, I'm going to start with, so down here is miscellaneous and it's already done. So I'm going to start with this guy that says 1 death down here. Does anybody want to guess what's not so deadly? I'm going to start with Liam and then I'm going to loop around. Okay, so Liam, you want to guess what this one is?
High wind.
Actually, I think I have to start with this one. I take it back. I have to start up here because the way I clicked them.
Oh,
Okay, so this one, what do you think is 135 deaths?
Hurricane.
So you see, heat is the highest. Heat kills the most, extreme heat. All right, take a guess, Liam. What do you think?
hurricane.
Hurricane? Let's see what it is. Come on, click. It's a flash flood.
Oh,
Cool. All right, so now we're gonna go to Jack. What do you think is this next one? Third most deadly.
Tornado.
Tornado?
No, something hurt.
It's a rip current. Okay, what's a rip current?
Water, it's like.
Wait a minute, Milo, what is it?
I just wanted
Oh. Chloe, what's a rip current?
Other than near lethal to Chloe's.
Yeah, what's a rip current? It's like what I talked about in the river. You got, it's underneath, right? And it's typically cold. Guys, stop. Nope, nope. Put them down. Do I have to remove all the pillows when you guys come? Come on, don't be dumb. So anyway, the colder water underneath and it's going faster than the water on top. And you're like, woo, swimming, and then suddenly you're sucked right under. They have rip currents, rip tides at the ocean front, real common. We have lots of rip tides. Many a surfer goes down when they don't expect to. All right, so Caitlin, what do you think is gonna be this guy? Fourth most dangerous?
Mudslide.
Mudslides, all right. Extreme cold, my goodness. All right, Yusuf, do you want to guess this one?
Tropical storm / hurricane.
Okay. Tornadoes, all right. Drew,
Tornadoes are more spontaneous.
yeah, you don't even know. Okay, you say hurricane? Okay. Thunderstorm, wind. So this is like when you've got, so the wind itself isn't going to kill you, obviously, but whatever it knocks into you or brings your way. There was a kid in Atlanta several years ago who had a pine tree limb fall on his head. He was a little toddler and he was in the hospital. He made the news for months. Yeah, it was terrible. And he did die eventually of it. Oops, I didn't mean to click that one. That was avalanche, which is crazy to me. Avalanche was that one. All right, so Piper, what do we think is this one here?
Fire weather?
Fire weather, good guess. High wind. Okay, so we have thunderstorm wind and then high wind. All right, Alex.
River flood.
River flood, winter storm. All right, Milo.
How many fatalities I can't see.
Yeah, how many fatalities? 12. What do you think's responsible for 12?
He's thinking.
He's thinking,
I
Do,
think
do,
hurricane.
do, do.
quick and pick, hurry up. Coastal storm. There's your hurricane finally, guys. All right, Parker, what are you thinking?
You can track hurricanes. Tornadoes are like 1
River flood. Okay, let's see. Oh, I'm gonna give him 3 because he is the first person to get one right. So there we go. All right. Okay, Bailey. This is 11. And your choices are fire weather, lightning strike, mudslide, ice, coastal storm, and dust storm. 11 deaths per year.
Yeah, I know.
Ooh, lightning strike. I bumped it. I'm sorry. No, 9 deaths per year.
Oh, okay, okay, that was. Fire weather, that sounds awesome.
Mudslide?
Mudslides. Dust storm. All right, James.
I mean,
8.
I think it's
I'd say.
Fire weather, mudslide, ice, or coastal storm. Mudslide. Fire weather. All right, Chloe, you're down to 3. You have 30% chance. What you think?
But I'll get it wrong.
that's the confidence we like to hear.
Pick one.
Ice.
Nice. You should do it. She gets 3. Way to go.
Oh, that confidence paid off.
Confidence has paid off. Ice is good. Now, obviously, ice itself isn't going to kill you, but what's it going to do? It's going to make,
Freeze the road.
it's going to freeze the roads. It's going to make
Well,
limbs.
you might die if you
Listen.
fall.
It can make tree limbs particularly heavy. They can fall, right? And then you can obviously slip inside. So now we're down to mudslides and coastal storms. What, hang on, let's vote. Coastal storms, let's see. What do you think?
Same amount.
Nobody. Okay, mudslides. Yeah, they're both the same. You're right. They're 1 and 1, so it doesn't matter.
We
All
all
right.
get points.
So now we have to move on to this next one, which is climate. All right. So we got to whip through this because we've only got half an hour. So let's see. Chapter 4, Earth Science, Climate. Yes,
Already did like.
Two pennies.
that's okay. Okay, thank you then. All right, so now we're climate.
More than just.
Okay. I already know the foot.
Okay, we'll have a seat. All right, so what's climate? So thousands of years ago, Earth had different weather patterns than today. Temp was cooler, jet stream is further south. So this is an easy one. Caitlin. Yeah, yep, there you go. Climatology. Wait, sit down. You said they can't see. So climatology is the study of Earth's climate. All right, now. Climate describes the blank weather patterns of an area. Oh, what are we looking for here? The blank weather patterns. Yusuf,
Average.
average weather patterns of an area. All right, so usually we're talking average, general, long-term. We're looking at all the same kind of stuff. So basically it's like a 30-year average. So it's a long-term average. So standard values for a location are determined by how many years? Who was just listening? Jack? 30. Okay, there we go. And they're not intended to describe usual weather conditions. Most conditions are recorded at where? Where no one lives. Bailey. No, not Bailey. I thought I saw your hand. Nope. Okay. Alex.
The middle of nowhere.
Nope. Jack.
The Arctic.
Say it, Liam. Airports.
Oh.
Because there's nobody living there. That's where they do a lot of the weather data recording. So changes in elevation, proximity to bodies of water can cause climates to vary, obviously. So what causes climate? A bunch of stuff. Latitude, topography, Drew, don't bend that chair. Closeness to lakes, availability, of moisture, global wind patterns, air masses. So these are different. These are like almost like they're not microclimates, but it's kind of more specific here. Yeah, that's a lot of whatever this is, BWH. Okay, so what causes climate? Latitude. We're talking about latitude. Different parts of the Earth receive different amounts of solar radiation. So what am I looking for here between these parts? Yes, Drew?
It's the name of the planet.
Yeah, what am I looking for? What's this little box going to be? Between 23.5 north and 23.5 south, this part of this area is going to receive the most. Do we know? Liam?
Tropics.
The tropics. Okay, that's what we're looking for. All right, so what do we call the zones between 23.5 and 66.5, both north and south? Bailey.
Temperate.
Go. All right, temperate zones. Very good. Where do we live? Temperate, but we are very close to tropical, right? So we get a little edgy of the tropical. And then what do we call these last ones? Piper. There you go, polar zones. So these are nearly always cold. Duh. They're polar. I would say that's obvious. All right, so topographic effects. All right, so water heats up, cools down more slowly than the land. So temperature generally decreases with altitude and mountain climates. So this was one of your homework questions. So if you go up a mountain, the air pressure is going to decrease. And we said this earlier, air pressure and temperature are what kind of a relationship, James? Directly proportional. When one goes up, the other goes up. So when you're at the top of a mountain, you're going to have less pressure. It's going to be cooler. When you come down the mountain, you're going to have more pressure. There's more column of molecules pushing on you, and you're going to have higher pressure. So climates often differ on either side of the mountain. So what side is here that's usually wet and cool? Caitlin.
Windward.
There you go, windward side. So what's the other one going to be where the air is dry? Drew. Leeward side. Okay, windward and leeward side. So in your homework, you had a question, and it was about Becky and Jenny.
I can't find it.
Okay, so no, it was online. So I think I like James' answer best because it was fun. But can you, James, can you, if you don't mind, explain why when Becky got back, so Becky was in Denver visiting her friend Jenny. And then she flew back to New Orleans, and when she got there,
He was a jerk, right?
no, stop listening. Yeah, she teased her when she was kids. Yeah. When she got there, her shampoo bottle, her little shampoo bottle, classic shampoo bottle was squashed, but she had a snow globe in her bag and it wasn't squashed. She thought somebody had maybe sat on her bag or something or crushed it, and she couldn't understand. So James, why was the bottle squished?
Switch because when it was in Denver, Colorado, at the altitude, there wasn't as many air molecules pushing down on it. So when it was brought back down to Louisiana,
Yeah, New Orleans,
where
at or below sea level, yep,
there was more air pressure.
Yeah.
air molecules pushing down on the bottles.
yep. I think one of the Benson girls have pointed out that she used some of the shampoo when she was in Denver. So obviously, so she would have left some air in the bottle, and that's Denver air, right? It's way less pressure. And you get to New Orleans and that air is squashing in on that bottle. So it's actually, there's a vacuum in the bottle now, so it's caved in on itself. Right. Yeah, and so if you ever travel to Denver and when you come home and you open any of your bottles in your, like in your suitcase, it's one of Jason's things. He'll get there with his contact solution. She's like, ready? Because it goes every time. So yes, you have to think about those pressure
No idea
differences.
what that was.
Yeah, it's interesting when you think about it. So air masses. So you've got air masses. We talked about these. They have the qualities of what? Where does an air mass get its characteristics? Its qualities. Do we know, Drew?
Where it forms.
Yeah, over the land where it forms. And then as it moves, it will change, kind of adapt to the land where it is now, but it will bring those characteristics, the heat, humidity, they'll bring it to another location. And that's where you start to get air masses. Now here's a dude. Look at this dude. This dude's cool. So classification of climate. Different areas have different climates. How do we classify them? What's this dude's name? This is Russian-born German climatologist Vladimir Who do we at? Go ahead, Liam. Okay, so this is a fun name. All right. When you see this weird German thing where you've got this OE business, you've seen this before, right?
Not too often.
Yeah, it often has a little umlaut. Yeah, but you've seen this. So here's how you do it. It's like you're saying like you would do like a regular O, but there's as in book on your lips. So it's Kippen, which is a weird, we don't use that. Kippen. Yeah, because we don't use that particular sound in our language, but it's Kippen. Yep. So Vladimir Kippen came up with all this business. So here is his system for tropical. So what kind of temperatures do we have in tropical zones, Drew?
Lots of humidity.
We asked temperature. What kind of temperature? Yeah, it's warm or hot. Yep, high. And some areas have up to 600 centimeters of what? What do we want? What do we want? What do we want, Jack? Rain or precip, but rain particularly because it's warm. All right, so this is where you get tropical rainforest, all this fun vegetation, right? And they tend to be around the equator, and they can be these tropical rainforests or savannas. All right, so here we go. Dry climates cover what % of the earth? Does anybody know? Do you know, Bailey? 60%, she says?
37.
30, okay, 30% of the earth. That's interesting. It's about a third of the earth is covered in dry climates. So what kind of precipitation do we have in a dry climate, Drew?
No.
Yeah, none or low, very low. Yeah, they have some, but not a lot. So these are arid places, semi-arid deserts, steppes, right? These are more humid than deserts. All right, so then we also have mild. Ooh, where's this? Anybody know where this is? I want to go. Where is it?
It's Greece.
It's in Greece. Do you know what the name of it is? It's Santorini, and it's gorgeous, and I want to go. Okay, there's Santorini. So these are mild climates. So I want some kind of subtropical climate here, influenced by high pressure. This is the southeastern US, warm and muggy. What is it, Yusuf?
Huh?
Do you know? Oh, your hands up. Do you know what this one's gonna be? No? Liam?
Humid.
Humid? Okay, so we're looking for humid. That's right. Okay, this is where we are. And sometimes Jason thinks it's funny when I say this, but I've heard people refer to our part of the country, which is warm, muggy, as the armpit of America. It kind of is. The armpit of America. But yes, all right. So we have marine, coastal. What are we looking for, Bailey? Oh, no, I keep thinking I see in your hand. I don't know what it is back there. It's in my peripheral vision or something. Liam. West. There you go. West Coast, marine West Coast. I don't know what it is. That's weird. It might be a bird or something behind the window that I keep seeing. I don't know. No, it's not you. I don't know. So these are mild winters, cool summers. And then lastly, we have this kind of mild climate influenced by Mediterranean Sea. Oh, that's where this is. These are Mediterranean climates. There we go.
I already got
All right, now what's this? These places have warm summers and some have cool summers, subarctic climates. All right, now your hands up, Bailey. There we go. Continental, but it is temperate.
Close
Yeah,
enough.
kind of the same deal. No, they are technically temperate. So experience rapid, sometimes violent changes in weather, extreme temperature influence because they've got warm coming from below, usually in this hemisphere, and cool coming from above. All right, what are these? This is an easy one. There's a polar bear, Milo. Yeah, Arctic. Oh, polar, same kind of deal. Yeah,
Close enough.
this guy Kippen just used different words, but it's the same thing.
Okay.
You've got constant cold, low precip, and there's variations in temperature with elevation. And in a microclimate, this is like a little localized climate, right? You can see how things are slightly different. Usually it's topography or water placement. So these are localized climates, like you climb to the top of a mountain, it becomes cooler. I know, that's beautiful, isn't it? So those are microclimates. Whoops, I didn't mean to bump that one. So heat islands. All right, heat islands, you see these a lot in cities. So these are caused by concrete and buildings. And the climate gets warmer because that stuff, it absorbs the heat, right? And then they radiate the heat. If you've ever gone from Atlanta, like at 4 o'clock or 5 o'clock in the summer and then driven up here, there's usually a degree or two difference between the city and up here. The city can get super hot because it just collects all that heat and all that concrete. So it's a heat island. Okay, so climatic changes. Now, this is what we're going to start looking at next week, are these two videos. So climatic changes. So these are changes that take place over extremely long periods of time. Geological records show that in the past, Earth was sometimes much colder or warmer than it is now. Okay, long time. That's what these next two labs are going to be about. So ice ages are periods of extensive, what kind of coverage? Oh boy, Chloe. Yeah, you got it. Glacial coverage. Yeah, there's glaciers everywhere. And then you get these little alternating warm periods, and they call those interglacial intervals. How many years ago was the last ice age? All right, Yusuf, do you know?
50,000 years.
He's pretty good. 10,000. Good guess though. 10,000 years ago. Now, have you heard of the Little Ice Age in Europe? That's a fun thing to look up. So the Little Ice Age in Europe was like, it's like a couple of years. And there were just certain weather systems, and the Thames was frozen.
The river was frozen.
Yeah, the Thames River was frozen. It was a big deal, and it stayed that way for a while.
Are we still in it, I think? You know?
Not. There's always going to be argument about the climate right now because it's impossible to really know without hindsight, right? So, like, yeah, when we watch these next two videos, you'll see what I mean. And I will tell you this: those videos that we're going to watch, they are older videos. So you need to keep in mind that the data now is different, but what we're watching them for is how the data is presented and how people have acted on that data more than we are the actual data itself. So what are these? These are short-term periods of climatic change, oops, sorry, I bumped it again. Seasons. I keep bumping my fingers. So seasons, yeah. Seasons is when you get your variations in daylight and you get different amounts of solar radiation. Why do we have seasons? Why do we have seasons? Boy, who can tell me? Who can tell me? All right, Caitlin, you tell me why we have seasons.
The way the earth is tilted.
Right, the way the earth is tilted. Because if the earth is tilted and your part of the earth is closer to the sun, you're going to get hot. And if it's the other way, you're going to get cold. Okay, so this El Nino, La Nina stuff, this is weird business, I think. I don't know. Several years back, we were in an El Nino. And it's all they talked about on the Weather Channel.
Niño mean child or something.
Yeah, it's the boy and the girl. So we have the boy, and this one is going to be what? What's the boy? Who's in Spanish class with Miss Jackie? Who's the boy? What's the boy? Drew?
Like the Spanish word for boy?
Yeah, what are we looking for?
El Niño.
Okay, El Nino is the boy, right? Okay, so there's our boy, all right? So this is when you get this warm current over here in the Pacific, and it pushes in towards the West Coast like this, and it kind of cycles this direction, and it causes some really weird weather patterns. And then this other one, the girl is going to be, this one's obvious. So Caitlin, go ahead. La Nina. Okay, so this is when you've got your trade winds blowing, but they're going to be stronger, and that causes it to be chilly on the East Coast. Well, no, on the West Coast too, over here. All right, so changes can be natural. Keep this in mind when we start our 2 documentaries. Changes can be natural. So studies of what? Ice core samples, fossils, and radiocarbon. What do we think we want here? Drew?
Climate change?
Studies of, sure, I tripped you out. Yeah, okay. Tree rings. Tree rings can tell you a lot. Did I share with, no, it's last year. I shared the bit about Stradivarius. Last year, I think we talked about Stradivarius. We talked about forests and climate. So Stradivarius violins are the best, most expensive violins in the world, and they're apparently have the best sound. And it's because they're made only from wood that comes from a specific forest in a specific place. And it has to do with the way the wood is structured based on how the seasons and the growing seasons were. Were they drought seasons? Did they have lots of rain? Did the trees grow a lot? Did the trees grow a little? And that impacts the sound of the violin. It's pretty fascinating. So you can study tree rings, ice core samples, and fossils. And then you can do radiocarbon samples, which is all fun. This will give you exact dates, right? And it can tell you about changes. So solar activity can be different, changes in the tilt and orbit. Remember, Earth's wobbling, right? It's wobbling as it's going around, and that changes things. And then volcanic eruptions, that can mess with the climate too. Again, they can be natural. So what's this right here? Who do we use the Maunder minimum to talk about, Milo? Solar activity, all right. So you have a period of very low sunspot activity, or you can have increased solar activity. And that will have an impact on your weather as well as your overall season or your climate for a while. The weather station here does some data with solar activity. So it's kind of cool. Yeah.
Nuclear weapons also.
I would imagine that would change climate. We've talked about nuclear weapons twice today. All right. So changes can be natural again. Earth's orbit. All right, so the shape of the orbit is what? It's right there. It's not a circle, it's an ellipse, right? So it's like an oval, yeah. And then more circular, and then it kind of keeps changing. It's a 100,000-year cycle. So when the orbit is more elliptical, the Earth passes what in relation to the sun? Alex?
Closer.
It's closer to the sun. And then when the orbit is more elliptical, it's going to be, Yusuf, farther from the sun. So that's going to change stuff too. All right.
Circular.
Yeah, more circular. So what's this? The current tilt of Earth is 23.5 degrees. So what are we talking about? Earth's what? Piper.
Tilt on
Yep.
axis.
Yeah, tilt on its axis. That's an easy one. So your angle is going to vary from a minimum of 22.1 to a maximum of 24.5. And right now we're at 23.5. Keep this in mind too. We're at 23.5 and it varies every 41,000 years. I want you to keep that in mind. Are we closer to the minimum or maximum tilt right now?
Max.
We're closer to the max, right? Okay. So when we watch these videos about climate change, keep in mind that we are closer to the max than we were 40,000 years ago. All right. So lower tilt angle may decrease weather, decrease in temperature difference between summer and winter, and it can lead to expanded glacial coverage. So if it's a lower angle, you may end up with some ice age type activity. So Earth's got a wobble. I love this. It's kind of funny to picture it, but you can see there, they've given you some access so you can see kind of where it goes, frame of reference. Look at it wobble about. So it wobbles every, 26,000 years it wobbles. So it's a very slow wobble. It's not like a Weeble wobble, which wobbles kind of fast. But about every 14,000 years, the axis tilts toward Vega. So sometimes it'll tilt towards the North Star, which are Polaris, right? And then sometimes it'll tilt towards Vega. So when it does this change causes winter to occur in the Northern Hemisphere when the sun is farthest from the sun, and summer when the Earth is closest. And it causes warmer summers and colder winters than those we have now. Now, volcanoes, we talked about this. When volcanoes explode, they spit all kinds of yuck into the air, right? Dust and ash and gases, and it can stay there suspended for a long time. It can block sun. And so in 1991, there was an eruption of Mount Pinatubo in the Philippines.
I like that name.
And it resulted in cooler temperatures around the world for a whole year. So one volcano can impact a whole,
It looks like Mr. Pinatubo.
Yeah, yeah, it does kind of, doesn't it? Yusuf, did you have something to add?
Oh yeah, like didn't the Tanjero or something in Indonesia.
Yeah, there's a big one there. Yeah, shoot, what's it called? Oh, Krakatoa. Yeah,
What impact did that have?
I don't know. I can't remember. I have to look up specifically. Drew, were you gonna add something?
Right, so two things. First of all, anybody who does this.
Wait a minute. Shh, shh, shh. Yes?
Anyone who doesn't know, which I hope everybody knows this, but that's the main reason why.
Shh, shh, shh.
That's the main reason why the dinosaurs are dead, not because of the actual explosion, but because of all the stuff there. And second of all, that's the main reason why nuclear weapons will.
Again, with the nuclear weapons today, yeah, this is one of the things that may have contributed to certain species of dinosaurs becoming extinct. Between this and asteroids and whatever, comets, all this other business, everybody has. Usually, I think it's probably going to be a combination of factors, really, that makes the most sense. So this is, I'll give it to you, the human effect, or sorry, greenhouse effect caused by humans versus the real one. No, I gave this one to you. So this results from retention of heat in the atmosphere. This is necessary. So listen closely to this. So the greenhouse effect, this is natural heating of Earth's surface, and it's caused by certain atmospheric gases called greenhouse gases. We would not be able to live here without the greenhouse effect because it keeps the right temperature on Earth. It's certain gases in the atmosphere, and when sun's heat hits the Earth and starts to bounce back up into space, it keeps some of it here. It insulates us. But it's theorized that we can produce too many greenhouse gases, which would be like carbon dioxide, that we can, or our industrialized nature, we would produce too much. And then what would happen is they can't get out. The heat gets trapped. More of it gets trapped than was before, and it can make everything hotter. And this is the whole global warming concept, right? So keep that in mind, because again, this is coming. So what's this? This is a rise in global temperatures. What do we call this? Milo. There you go. Okay, so global warming is your rise in global temperatures. So your worldwide temperatures. Now, worldwide temperatures have shown an upward trend over the past 200 years. How many years was it for that tilt to shift? Do we remember?
41,000 years.
Yeah, okay, 41,000 years for the tilt effect. Okay, and then 200 years we've seen warming. So this 200 years, because humans have been industrialized for about 200 years. Think about, what year was it 200 years ago? Like 1800. When was the Industrial Revolution roughly? Yeah, right then. Okay, in that time period. So that lines up with the Earth getting warmer. So that is part of the hypothesis of global warming. So if this trend continues, what do they say will happen? Polar ice caps will melt. Sea level might rise in coastal cities. Deserts could spread into fertile regions, and a frequency and severity of storms will increase. So while they agree that global warming is occurring, a lot of scientists are going to disagree about the cause of it. And that's what that's what the next two labs are going to focus on. Now, I don't remember exactly, but did anybody remember what Greta Thunberg said exactly when this was going to happen? No, stop that. But she said exactly when this was.
It was like, she said it was gonna be like.
It was like 20 years, or I mean, it was very short time period. And that was probably highly underestimated, but yeah. So automobile exhaust is the prime source of atmospheric what? Do we know, Jack?
Gas.
Yeah, which gas are we talking about?
There's actually several predictions.
Yeah.
Most are ignored.
What's the one we're concerned with? That we're talking about CO2. We're talking about greenhouse gases. Yeah.
There are a few others.
There are.
Pretty small amount.
Yes, exactly. So industrial emissions and burning of fossil fuels result in the release of carbon dioxide and other gases. And then when we chop down trees, the trees are not there to breathe up the extra carbon dioxide. So there's more. So this is this whole concept of global warming. So environmental efforts. So can we combat global warming by conserving? What are we going to conserve? Yusuf, do you know? What are we conserving? Think. Piper? Energy. We're conserving energy. Okay, we're conserving energy because then we're not burning our fossil fuels. All right. So this is obvious stuff. Turn off stuff when you're not using it, right? I mean, like turn down the thermostat in the winter and up in the summer. Lordy, guys, this is like my mother-in-law has her thermostat way too high in the summer. I can't, I'm dying. And then recycle, obviously. Recycling is good for many reasons, but recycling is one of those things where you have to really look into it and how your area does it, because sometimes it takes more energy to recycle than it does to not recycle. So if you're doing it for the purpose of saving energy, it's not always efficient. If you're doing it for the purpose of not filling up a landfill, that's different, right? That's very different. It's like the electric cars. You got to plug them in, right? So you get your Tesla and you plug your Tesla in. Okay, where's your power coming from that you plugged your Tesla in? Yeah.
Nuclear, fossil fuels, possibly water or wind.
Exactly. So if you live in a place where they're doing coal burning and you've plugged your Tesla into the wall, are you really conserving any energy at all by driving your Tesla? You making the environment greener? You're so not making the environment greener. All right. So these answers I will, they'll be for you to come look at if you want to come look at them. You know where to find them. All right. Now, before you take off, I'm going to tell you guys, be sure. Oh, Caitlin, you say what you want to say first.
A couple of years ago, James and I saw, well, I'm not sure if you remember it, but there were lots of people holding up signs, like, on the sidewalk. It said, honk if you believe we can stop global warming.
Oh, well, all the cars drive by.
Yeah.
That's interesting. Yeah,
This makes.
right. Okay, so before you leave,
That's hilarious.
every week after class, what do you receive?
An email.
An email. Have you been reading your email every week?
Yes.
You need to read it if you're not reading it. There will be information in there, especially this one and the next one, concerning these two documentaries that we're going to watch. Hold on, don't go wandering out. Listen. And it will tell you what you need to do as far as being a little early or staying a little late. Okay? All right, now I'm going to turn around your coins. You can come get your stuff. And you guys have an awesome, thank you. Just put it right here. You guys have a good Thanksgiving. No class next week. I will see you when you're back. I'm gonna let you go, Lil and Sky. We'll see y'all later. Sorry about the microphone at the beginning.
I'm so sad. It's okay.
All right. Catch you guys
Bye.
later. Bye.
Some button down.
You can